We're now moving on to a question and answer session. We're opening questions to the floor. We'd appreciate if you can introduce yourself before you pose the question. And if there is a particular person you would like to direct the question to. Okay, over to you, Doctor.
Thank you very much. So we had 6 presenters, starting off with Empower. The presentation dealt more with the policy and the impacts of distributed generation. We had REC Solar, the manufacturer of solar PV. We had 2 companies presenting on floating solar and 2 more companies presenting on structuring and putting projects together. So we have almost half an hour to go through with our Q&A session. And we have roving mics in the audience. And so please raise your questions and identify yourselves and present it to the particular speaker if you like, or if it's a general question, you may say so. Please go ahead.
Thank you for the nice presentations and sharing the experience. And I'm formerly from the utility and presently operating IPP power plants based on renewables. And we have wind power plants as well as solar, operating 20 megawatts of solar in Sri Lanka. And I would like to know the overall economics of tracking systems, because we have 20 megawatts with tracking and we have some issues in maintaining the tracking systems and associated costs. So maybe the operators or solar developers might have experience on the tracking systems and the overall economics kind of things if you have the experience.
So the question is about tracking systems, tracking, and the overall economics, the additional costs perhaps, if anyone of you have experience on this. Yes, can you pass the mic? Yes, this is the mic. Just press the button.
Sir, thank you. Can you hear me? Yes. So tracking systems, just to clarify, my experience from this is from my 8 years with Scotec Solar, when we followed closely what happened to technologies in this sector, and it is very interesting things that happened. Some years ago, it was normal to say that tracking systems, and everybody knows what tracking systems means, is that you can have both single axis and double axis tracking systems when you have a solar PV installation. The single axis tracker system is the most used, and what it means is that you actually turn the panels towards the sun in the morning, and then during the day you stabilize, then in the afternoon you will be able to turn the panels towards the sun which is setting. This means that with a tracking system you can get more out of the solar radiation, and in the beginning there was a lot of concern about whether these systems were actually robust enough, but the experience now is that the experience that we had in Scotec was that the solar yield you could get from a tracking system would many places come up to almost 20%, 15-20% more solar production, power production, and the cost difference can be as limited as maybe around 10-15% higher. So very often it will be attractive to install a tracking system, and the experience so far from the qualified suppliers is proving very, very good. Of course, there are issues. You have a higher O&M cost, so they have some additional challenges, but basically it works. And maybe some of my colleagues here would like to add.
Yes.
So from the experience of REC selling into developers like Terje and others, we see that in some cases, especially from the experience in Australia, lately there's been added use of single-axis trackers in larger installations. However, there is also a very good practice in the solar industry to keep the system simple and avoid moving parts, something that's going to stay there and without daily maintenance for 20 years, should be as easy as possible. That's also a learning from a lot of installers, I think. Obviously, you need to maintain and watch after a system that has moving parts.
Mr. Vijaypal, are you satisfied? Fine. We can move on to another question. Yes, please.
Try a different mic, okay. I'll just sit down because I'm at the front. My name is Lucky Disanayaka. I'm an entrepreneur. I'm a developer. I have been working in Sri Lanka for the last... I was born in Sri Lanka but grew up in England. And I've been working here since 2013. And I have a business in energy and biomass, where we look at biomass energy. But I have, in order for us to be successful as a business, I started looking at biomass power generation using pellets or chips to make energy. And partly as a result of the fact that we have a small distributed system, and nobody's really interested in talking about $25 million worth of investment in the world outside of Sri Lanka, I then started to look at the opportunities in solar as well as biogas. Now, I'm working with a number of entrepreneurs who are working alongside me, and we have the possibility to do a lot of changes in this country. But there's a couple of problems that we have. And the first one is rupee depreciation. Yeah? When you sit down with anybody who is funding anything into Sri Lanka, the first issue we have is the volatility of the rupee. So profits basically evaporate. If you look at a 20-year horizon, the CEB is paying 23.44 for biomass, 22.15 for solar, 22.15 for biogas. But those are for time horizons, and then thereafter it reduces. But solar in particular would be debt to equity 80-20. And when you have 80% debt and you have a rupee depreciation, it's a tough call. So what I want to understand from you is, I believe that we have the opportunity to put rooftop solar, biogas, biomass, OTEC, a whole pile of different things, because Sri Lanka is blessed with sunshine, it's blessed with water, it's blessed with trees, and it's blessed with 9 deep canyons from which it can raise, thermal OTEC solar. But the problem we have in this country is the problem of the country's political situation, the instability, and the rupee depreciation, and of course, the lack of interest on behalf of the CEB to do anything on this front. So I would like to understand how you see us getting past these problems.
Yes, it's a tough question. Would you want to have a go at it? Yes. Can you pass the mic, please?
Thank you. The question actually relates to what can Sri Lanka do to actually make it attractive to invest in renewables as a private investor. And I think you address a couple of things. Let me first say that the key is here to distinguish between whether you're selling to the utility or whether you're selling to private industrial customers. So this is one thing that I would like to address, because I've noticed that in the regulations in Sri Lanka, you're actually allowed to do your own generation and have a net metering. And what is then the natural follow-up of that, of course, is that you can also allow private investors on site to actually sell to the utility, to the company. That would be one way, but I'm just saying this is the normal path internationally, that a company in Sri Lanka who is doing food processing or hotel or whatever, they should not need to spend their balance sheet to actually, or their money to actually install a solar plant. They should be able to enter a PPA which secures solar to their installation and saving money and also becoming more green and using their resources. So this would be the first recommendation, that Sri Lanka of course there are other ways. You can do it via leasing and other models, but that is one way to work with it. So that would be my first recommendation. The second thing is, as you say, relates to the depreciation rules. There are also many countries that have depreciation rules that actually allows more accelerated depreciation in the tax regulation, and that of course also can make the investment more easy to carry. I don't know where Sri Lanka stands there, but that is also something which is normal. A third thing which is quite normal is that there are in many countries certain tax incentives, tax holiday, reduced income tax for installations of this character. So even if you don't go the full way of having feed-in tariffs, there are many ways you can actually do to stimulate private investments in this area. And I think a couple of the things I mentioned should probably be on the focus. And then, of course, when it comes to the capital cost, what is important is that there are international finance, which is cheaper than probably what you will get in Sri Lanka. And that is also key here, is that if you get able to bundle project, you get a critical size of investments, then you will be able to access international finance, which can bring down the cost as well. I hope that answered part of your question. Thank you.
Anybody else who wants to add anything to the answer? That's a question or an answer? Comment on that. Yes, okay. Comment on the question, please.
I'm Gavini Rajapaksa from Peradeniya University, and I would like to add on to the answer that was given by the gentleman there. Because, I mean, in Sri Lanka, of course, you have difficulties. I know that politically, of course, I mean, there's a very pathetic situation we have. But, of course, in Sri Lanka, we have 2 BOI zones where the tax is tax-free, Board of Investors, in Katunayaka as well as in Avisaville. So if you have if you can establish an industry in these BOI zones, then, of course, I mean, you don't have to pay any tax-free. So you can think of those things and negotiate with the government to have an industry in BOI zones. Thank you.
Yeah. Yes, you can. You can, yes.
So the first thing is that, yes, that is true that we have BIA zones, but the IMF rules meant that the tax incentives that were given to investors on BOI and tax incentives have been taken away. So that doesn't exist. In terms of rooftop solar, what you mentioned is abundantly sensible. But the problem is that we don't do that in Sri Lanka. Here in this country, the CEB's rules are that the only party that is using the actual energy, can receive the energy. So leasing is not allowed. The word leasing itself is problematic because of a million other issues. So you can't easily get an investor to come in and put rooftop, solar on your rooftop and sell you the energy. And the other problem is that they don't necessarily pay you, so you have that issue as well. I mean, I have found solutions to this, so when we're finished, I would like to sit down and talk to you. But, what I think is, I hope people are here from the CEB, PUCSL, SEA. It is a travesty that this beautiful country imports oil and coal for energy generation when we are blessed with renewables. And if we can go back to what we were in the late 90s, which is almost 100% renewable, we would set a South Asian example to what is possible, just like Costa Rica is doing in South America. And then we will have a different conversation with the world outside. And plus, as this gentleman very kindly pointed out, from 2020, we will be able to sell our carbon credits. By the way, my biomass business, we are funded by foreign investors and the government of government of Australia, England, and Switzerland. And Norway is also participating in that program. We will be registering our carbon in partnership with South Pole to the worldwide carbon markets, just on the trees that we register. So if we can do that for this, why not do it for all the other renewables, and we will have something to sell. We will be able to meet our obligations under Paris. So we need to think. I hope this seminar will help those people who are doing policy decisions and long-term planning to really think through what the CEB is demanding right now, which is more coal-fired power plants, which is truly insane and would be a phenomenal stranded asset and a drag on the finances of this country.
All right. Anybody from CEB, Ministry of Power, Sustainable Energy Authority, Public Utilities Commission would like to respond? All right. Let me conclude this particular question with a short comment. I cannot respond to all the questions that or the comments you made. Sri Lanka has a problem of electricity pricing. So if you put up solar PV and try to sell it to an industry, you are sure that no industry will want it. They get it from the grid at 13 rupees. Sri Lanka, 70% of Sri Lanka's electricity sold is subsidized. 70% of the energy cross-subsidized by the other customers who are commercial establishments like this institution, and about 5% of the sales to households. So what is happening now is that the customers, of course, why that is so is yet another government policy to support the low user households, assuming that they are poor, and to support the industries, assuming that they need support. So therefore, that is also a requirement from the customer community. So what is happening now is that the commercial customers as well as the high user household customers are moving away from the grid. So therefore, the share of electricity that is expected to cross-subsidize the low users as well as the industrial customers is going down. So therefore, the overall business model of the electricity sector is not correct. So if industries also agree to pay 20 rupees for electricity, which means almost a 60% increase in tariff, if a low user household who is using 30 kilowatt hours per month, and about 1.5 million of households are in that category, they are paying 2 rupees 50. If they also agree to pay 22 rupees, then I think this equation will quickly come back to what you and I are discussing here. So there are more fundamental problems. These are nothing to do with, perhaps in a certain way, Sustainable Energy Authority or CEB or a particular government institutions, but these are things that came for a long time in the system, and no government is willing to touch the electricity pricing situation, in spite of many attempts, many formulae, many initiatives by the Regulatory Commission as well as by CEB and LECO from time to time. This subsidy is continuing because the government thinks that a certain category of people cannot pay for electricity. But as you all know very well, the same category of people very happily pay mobile telephone bills of thousands of rupees.
Can I just add one question comment to that, because this is a key discussion. Let's take example like Kenya. In Kenya, you have the same situation. The grid, the industrial customers, commercial customers pay a relatively high price for the electricity from the utility. They are discovering that by installing PV, but not installing themselves, but entering a PPA with a local project company that installs a 1 megawatt plant at a roof, they can save energy costs. They can also actually support the grid, because the grid gets a weaker pressure during certain parts of the day. And they also discover that in the export markets in Europe and Japan, elsewhere, they get a higher value because they can show that they are reducing their carbon footprint. So what you're saying is that the situation is in principle the same in Sri Lanka, except that you do not allow those same customers to actually have a local project company to sell to there. That means that the company who is getting out of the grid is actually have to go to diesel. So your current regulation is actually stimulating companies to reduce the use of grid power and replace with diesel, because you don't have regulations that accommodates solar investment. Is that correct?
No, nobody
is that
does
correct?
it. Nobody uses diesel for electricity generation because it costs about 30 rupees. The grid is much cheaper.
Yeah, but what do they use there when you say that they go out of the grid? What do they then use?
No, they go out of the grid because these are the commercial customers who are charged 24 rupees to 25 rupees, as well as the high user households who are charged up to 35 rupees. So they go out of the grid by fixing solar PV.
Yes.
Not necessarily going out of the grid, but using the grid as a bank,
yes,
effectively a free bank, and not pay anything to the grid, but perhaps produce solar PV at around 20 rupees a kilowatt hour. So the scenario is a lot more difficult on Kenya, because I know I wrote the regulations for Kenya.
Yes.
So the situation is a lot more different to what you see in Kenya. It's a 100% electrified community that we have over there. whom the politicians think that are not willing to pay for their electricity, which I think is not correct.
So I understand the only difference then is, as you say, the question of whether you're allowed to buy, you're allowed
Yes,
to do
of
sell.
course, yes.
that.
Not allowing a customer to buy from somebody else, another legal entity, is, I think it's not correct. So it should be allowed if the economics are right. So that's a related but a different argument. Thank you. Can we move on the same question? Yes, can you pass the mic, please?
Okay. So I wanted to add one element. Lucky brought up several obstacles that face the renewable sector, or how shall I say, a more green development in this country. I think there is a large number of obstacles and lethargy within the system that is creating problems for the development of green energy, that is creating or slowing down the development towards a more sustainable economy in this country. And I think that is partly because of a political system which is, how shall I say diplomatically, not very efficient. But it's a political system which is also very susceptible to public opinion, public outcry. And I come from civil society in Norway, where civil society is pushing politicians and bringing in opinions and alternative ways of resolving the problems in the country. I don't see that so much. It's there, but there could be much more. I think that educational institutions like the universities we have here have an important job to do to educate their students of the situation that we are facing globally and nationally when it comes to energy, when it comes to development in the wrong direction. And when these people go out in the streets or when they write in the newspapers, the politicians in this country, they listen to what the voters say, because what they almost always want is to stay in power. So there is a large potential for more political pressure. The other day, there was an article in the newspaper saying that the president now wants coal power. I still haven't seen any letters to the editor from enraged citizens saying this is, yeah, you know what it is. So there should be more public engagement.
Fine. Can we move on to, can you be very brief? We want to
Yes,
move
I
to
can be
another
very
question.
I think, public engagement doesn't come just from a university. Public engagement comes also education of the normal people. I have, so far I have understood that yes, renewable energy is good, but it's expensive or no, it's not intermittent, it's not working well, while LNG or coal is the best and most reliable power supply. This is not correct. You have PV or photovoltaic that you can combine with storage, batteries or hydrogen, and it can be very, very reliable and clean. Thank you.
Yes, can we move on to another subject area? We had some interesting presentations on floating solar, and solar PV manufacturers are here. I'm sure you have certain burning questions on these subjects. Yes, please identify yourself and proceed.
My name is Charles Edward Vikramaratne. I'm representing MECMA Cochrane Lanka Private Limited today. I would like to ask a general question from all of you, from all the presenters. Number one is, what is your average panel efficiency of your panels, roughly what you all have developed now? And also I would like to know the floating technology, what you all have developed. Somebody mentioned that you all will be using pipes instead of any other structures. What will be the lifetime of these pipes and things, which normally when it is very close to the sea area or any other area when you have it with the water? Because average lifetime of a solar panel is about 15 years. If the floating solar does not last for that particular level of lifetime, I think that will be a disaster situation, especially in a country like Sri Lanka. or any other place? Then I also would like to know what will be your overall efficiency of your system.
All right, the
PV.
first question is for REC Solar, I believe.
On our solar panels efficiency, they are standard multicrystalline today at around 18%. With our new N-type mono, we can go up to close to 20. This is due to the special technology we do. It's a twin peak, it's called, as you saw maybe from the picture. It's divided in two, which reduces the internal resistance and thereby increasing the energy yield from the process. And this is a project that was developed by REC and introduced to the market in 2015, and it's quite a large development in bringing more power from the same form factor. On the floating panels or floating systems, we have done a large study and talked to all the suppliers for the test bed in Singapore, and they are happy to guarantee their systems for 20 years. When it comes to the lifetime of PV panels, we can easily, we are guaranteeing the output for 25 years. We can see from the experience that the early installed systems in Norway in the 80s are still producing. Of course, the technology was lower at that time, but we can document now for many years that 20 years plus is quite realistic as a lifetime for a PV system.
All right, any further responses on, particularly on floating solar, about the lifetime, correct? Lifetime of floating solar, yes, please.
I think that the basic element in most systems for floaters is based upon solid plastic constructions. Many are using, like the pipes that are used in many systems is water or drainage pipes, solid pipes which are designed to be used in the water systems in the ground for 50 years or more. We don't have 20 years of experience or 30 years of experience with this as floaters, but we are pretty confident that these pipes are quite durable.
Yes, does that satisfy you? Are you all right? Any, just a moment. Any more questions? Yes, after him, I think Lucky, you can raise your second question. Yes. Yes, please proceed. Please identify yourself.
It's again, I'm Professor Kandasamy from JetWing University.
Yes, please hold the mic closer so that we can hear you.
It's again about this floating solar system. You know, even if you have plastic bottom of the solar cell, you know, it is in a humidity atmosphere, so I can expect simply lot of corrosion problem on the top of the solar cell, especially connectors and other things. So are we doing anything to prevent that? That is one thing. Another question, it is on the top of the water, so we can expect simply wind-driven waves on the top of the water. Are you having any mechanism to absorb that wave type variation? That is my second question based on that. Third one, compared to roof solar cell, what is the percentage of efficiency? We can calculate, but practically I am asking you, any different in the efficiency period, efficiency and other things? These
All right, three questions, one on structures, the other one on waves, and the third one on efficiency. All right.
So on the structures, if you actually if you go into REC's installation module, installation, what's it called?
Manual.
Manual, yes, which is available on our website. There is a special section on how to install the modules on floating structures. So if the modules are installed according to the specifications, we give full guarantee for the 20 years for these modules. So that's not affecting the guarantee. That's of course because we have tested it extensively. We always test 2 or 3 times the guaranteed loads when we are doing this internally. And I can tell you that we have done extensive damage to our panels to be able to secure these warranties. We have an IP67 protection on the junction boxes and everything. So that should be okay. The efficiency compared to the rooftop, we demonstrated that with our 2 systems, which are actually located only 500 meters apart. So they have exactly the same solar installations, and we can see about the performance ratio is about 10% better for the floating system. When it comes to the wind load on the system, we are using standard flat roof mounting structures. They have been tested and guaranteed for certain wind loads. So we are limited to whatever the manufacturers do. Of course, there is special care. You have to study the wind conditions and everything in detail before such a system is deployed.
But I think your question was also related to whether you actually harness the wind energy or the wave energy. Perhaps the answer is no in your systems. You capture the wave energy as well in your system. No such things. Right. Any further comments from the panel before we move on to our last question? Yes, please.
I would just like, from an investor perspective, I would say that floating solar PV is probably something for the future, but as an investor, to invest in such an installation, I would then look at the company who is supplying and see whether that company is prepared to put up the guarantee that I am, as an investor, necessary to have. So if that is what happened to trackers. In the beginning, investors were very skeptical, but then the tracking suppliers came up with the guarantees, and then the market started to grow. So I think the same will be here. But I would like to stress that the question of solar hydro hybrid, PV hybrid solar hybrid that I raised, is not necessarily linked to floating. What I referred to was the fact that you have many reservoirs in Sri Lanka with hydropower generation, and you can probably do a very good, very smart thing by looking at possibilities to connect PV on the ground, some kilometers or 2 from the same substations, so that you can use the same infrastructure, and then you can start balancing, because there are systems you can put in place so that you can actually then balance so that if there is a big cloud with rain coming, then you can actually then start maybe a turbine again. So the idea here is that I want to promote is the idea of integrating PV and hydro into a balancing system so that you can actually save water. That can be done with a floating, but it can also be done with a fixed installation.
Fine, thank you very much. And the last question from you. Can you get a mic here, please?
We have 33,000 irrigating tanks in Sri Lanka, which are King's built, and some of them are incredibly interesting in how they're structured. So you have a cascading water tank. So you have a very large water tank, and then it goes down and down and down, and then it distributes water to the villages. Now, in my simplistic thinking, is that if you can reverse some of that water flow, you also have the possibility for storage. Yeah. So just something to think for the people here is that if you use the energy and you can actually pump the water back up again, if you want it to at night, which is why they keep building coal-fired power plants in Sri Lanka, is to have the stuff they need at night, then you may be able to do something with the water systems that are already in place, that have been built 2,000 years ago.
Well, you're talking about pump storage power systems, and there's been a feasibility study on that, and I believe there is a ranking of sites, but don't forget you need energy to pump it up, and that energy should be cheaper than the energy you get it back, and you lose about 20% of energy in the process. I suppose we have finished our time and run over by another 3 minutes as well. So we need to conclude there. Thank you very much, my audience and the persons who actually raised the questions. And to my panel, thank you very much for your presentations and responses. Thanks very much.
Thank you very much. That proved to be a very, very responsive session. Thank you for those wonderful questions. And of course, our resource personalities, thank you for your response. And thank you, our moderator. Everybody put your hands together for Dr. Sevalapitiya for doing a great job. Well, just before we move on to the next technical session, we've got a very special presentation to be done. Can I please invite the President of the Sri Lanka Energy Managers Association, Mr. Ronald Commister. Engineer Ronald Commister, can I have you to step forward, please? This is from the Sri Lanka Energy Managers Association to remember and to thank the visiting delegation from Norway to Sri Lanka from the 6th to the 12th of May 2018, where we laid the foundation for a long journey of partnership between Norway and Sri Lanka on clean energy technologies. This is from the President and the Board of Directors, Sri Lanka Energy Managers Association, Colombo, Sri Lanka, presented to this lady who will receive it on behalf. Everybody put your hands together from Rector Berit Rockney, who will receive this very special token. Presume they're going to reciprocate with another token. There's another token. Let's have a round of applause. Thank you very much. So we're ready now with our final technical session before we break for lunch, or we end with lunch. And this is on wind, hydrogen, and fuel cell. And let me invite our session moderator, who is the immediate past president of the Sri Lanka Energy Managers Association, former deputy vice chancellor of the University of Moratuwa, and presently the dean, graduate studies and research from the Sri Lanka Institute of Information Technology. Ladies and gentlemen, it's my pleasure inviting this dynamic personality, Professor Rahula Attalage.
Very good afternoon to all of you. Thank you for the introduction given by my sincere schoolmate, Faisal Bonso, top-notch compeer in Sri Lanka, and also to be invited to moderate this session 2 of this clean energy seminar, with session 1 already completed. And my task would be to moderate the sessions, which would be comprised of 6 presentations. And I would be very briefly introducing each presenter just before the presentation, and also would indicate the rules of the game because of the time limitation. And could I kindly invite the presenters to the head table to take their respective positions, starting from, I have to excuse myself in my poor pronunciation of Norwegian names. First would be Mr. Stromgren. Yes, please. Then second would be Mr. Thor Solheim-Slid. Third would be Miss Krina Sylvia Ilia, followed by Mr. Arne Groundal. followed by Mr. Sturl Pedersen, and the last presenter is Mr. Dahl Johan Schopen. I excuse myself if I have pronounced incorrectly your names, and each presenter will be given an allocation of 10 minutes, and I would very kindly request the presenters to stick to the time allocated, and also I would try to signal the presenter when you reach the time limit of 8 minutes. And then the 6 sessions, presentations would be followed by a question and answer session, which is, according to the schedule, is about 10 minutes. So we should manage the time, and we have to break for lunch at 13:45. That's 1:45. So hope that would be manageable. And without further ado, would like to invite the first presenter, as per the schedule, Mr. Trond Stromgren from GC's Subsea Maritime Association, and the Senior Advisor, Renewable Energy and Hydrogen Value Chain. The session 2 focuses on the wind, which is well established, proven and applied technology, hydrogen and fuel cells, which is no longer emerging, tested and being introduced to the marketplace. So with that, can I request the first presenter to take your presentation? Thank you.
Okay, thank you for being here. And I also love to be in this country of smiling people. I'm so happy to be here. I work for 2 maritime clusters in Norway, industry clusters, and I'm focusing on the maritime aspects. And bear in mind, the population in the world is increasing, and the increase in population that is near the coastlines around the world. That makes it interesting to look at marine renewable energy. And this is from the Orkney Islands, North Scotland. There's an enormous amounts of energy in the ocean. It's enormous amounts of energy in the ocean, and like Sri Lanka is an ocean country, you have a perfect situation to get energy from the ocean. My background is I work with the petroleum industry for some years, and Norway is leading in competence doing oil production and gas production in the North Sea. In 2014, the price went down. That means we have to focus on other issues. Then we started focusing on marine renewable energy. Like in the North Sea, some of the players I am collaborating with have built a number of wind farms, Dungeon, Sheringham Shoal, and are planning to build more farms. In Europe, there has been built 15 gigawatt of offshore wind until now. Statoil is heavily involved in the production. They have built or decided to build 6 gigawatt of offshore wind. And what is interesting now, that the next farms that are planned and decided to be built, they are built without subsidies. So they deliver on commercial basis electric power to Great Britain, to England, at the same cost as it costs to produce the electric power on land England with thermal power plants. So that's an interesting thing. My job here, I have no personal profit of being here. I'm just a helper. My job is to connect those of you who want to know more to the companies in Norway. I represent like 150 companies, and some of them work with marine renewables. So I can pick up the phone, I can call, a number of these companies. All of them have been involved in building and running and maintaining these offshore wind farms. So, what else from the ocean? Wave energy. And that's a challenge because the waves are so strong. They just smashed lots of the things that are put in the sea. But some companies have tried now to find some new solutions, like this one, a Swedish company, and this is running in Norway, producing energy for the grid. One of my also colleagues have this invention. It's he can take up the energy from the waves with the oscillating water columns, and this method could also be mounted on existing infrastructure. That means on the ports and things already in the ocean. This could be fixed and then produce energy with very little cost. And then, last one, tidal power. The good thing with tidal power is that you know when it's coming and the amount of it. So we can design exactly the design of these turbines. This is a new invention, hopefully going to be produced in Norway and tested maybe in some years. I'm also heavily involved in hydrogen because what is a problem with tidal and wind and wave, you cannot control it. You cannot, regulate it. So the regulation must be by storing this energy either in batteries or in hydrogen. And that means from wind, solar, tidal power, wave power, the electric power can then be transformed into hydrogen by electrolysis. And that's just, we can buy these things. They are, you can buy them in Norway, in England, in Japan. Then you can store the hydrogen, store the wind, store the solar energy. The hydrogen can be transported to other places and to boats and to refueling stations for cars like we have in Norway. And then the cars, the buses, the trucks, the boats can run on zero emission basis. So I'm also I'm leading this project, designing this vessel and building it. It's 150 passengers. It has 2 electrical engines, 600 kilowatt each, runs with 28 knots. And you see those blue tanks, they are for storing hydrogen, like 400 kilos. And the white small boxes are the fuel cell boxes. So then we take the hydrogen into the fuel cell boxes, and the fuel cells, they make electric power. Cables down to 2 electric engines inside the catamaran hulls. And that is 100% zero emission as long as the electric energy that is used to make the hydrogen is zero emission. So hopefully in some years we'll build this boat. We just need a guy or a woman with lots of money in their back pocket, or some company or county council that want to buy this boat. Then we will build it. These are a number of the companies I'm representing. And I'm also, I must say, I'm involved in many different international projects. I have a position in the International Energy Agency, and I'm involved in different projects and board in the European level. And what I have never told anybody before outside Norway, that I'm also a founder, and I'm doing also part of this technical development of a huge project combining offshore wind and hydrogen storage. And that makes a possibility for Sri Lanka, because the IMO, International Maritime Organization, they make no strict regulations for cutting emission from ships. You cannot enter Norway or USA with a ship on heavy oil. That means hydrogen will soon be powering of ships, and then there Sri Lanka and also CEB, if you grab the chance to build offshore wind farms around Sri Lanka, store this energy as hydrogen, and then nearby you have the great large shipping lines, international shipping lines. You can sell this hydrogen to the shipping industry passing Sri Lanka. That's my idea, my gift to you now. So I'm here just to be a connector to many different businesses. So I'm also here to tell you that on the table outside, there's an invitation for an international conference in Norway in October, which I'm part of, about marine renewable energy and hydrogen. So everybody here is invited to this conference. Please find the invitation outside. I have to leave tonight for Italy. I'm also busy after the lunch with meetings, but please, anybody who wants, grab me during the lunch. I will not eat, I will talk to you. Thank you.
Thank you very much. Sticking well within the indicated time. And thanks for throwing light on the applications of the value chain of hydrogen and also the portfolio of activities that you carry out with your company that could be useful to our investors and professionals in Sri Lanka, and looking forward towards the application of hydrogen. I would like to request all of you to give a round of applause to our presenter for the excellent presentation made and sticking to the time. And next in line would be the second presenter, Mr. Thor Solheim-Slid. He's from Greenstat. He's a green energy analyst. And I would like to very warmly welcome you to the podium for your presentation.
Okay, my name is Tore Solheim-Slid, as he put it. I have my background from energy technology. I'm a civil engineer in energy technology, and I work for the Norwegian company Greenstat. Our desire is to reach a zero-emission world, and we have established several subsidiaries in order to give our best in order to achieve this goal. One of which being Greenstat Hydrogen. Okay. Greenstat Hydrogen aims to be a producer of green hydrogen, which means production of hydrogen via electrolysis from renewable sources. This being on small or large scale and for sale locally, distributed nationally, or exported globally. For zero-emission markets abroad. Greenstat Hydrogen will produce hydrogen through renewable energy, as I said. For Norway, this means mainly cheap hydropower. For most other countries, such as Sri Lanka, this would mean solar or wind power. And this continues to become more and more relevant as the prices for these energy production technologies continue to decrease. And the customer decides whether the purpose for hydrogen would be for transport sector, for maritime, for industry, or for energy storage. As I gather, the transport sector in Sri Lanka represents about 40% of the emissions nationally. And here, obviously, hydrogen could play a vital role. Also, from what I've heard, about 90% of your cargo is done on road, so in the transport sector. And as a general rule, hydrogen has its best advantage when you utilize it in the heavy-duty vehicles, meaning trucks and the public transport, being buses. Another major advantage or possibility for Sri Lanka to utilize hydrogen is through energy storage, as has been previously mentioned. From what I gather, your potential for increasing capacity of hydropower is limited, leaving you with solar and wind power if you are to go 100% renewable, which you aim to do. These being intermittent, you need energy storage, surely, and hydrogen, as Trond mentioned, is a very good way of doing this. And we have already received an offer for collaboration on such a project. And I hope that more will come as the day passes. Today, most of the world's hydrogen is being produced through steam methane reforming. This is, when not considering carbon capture and storage, this is today cheaper than electrolysis on a very large scale. However, with decreasing prices for renewables and electrolysis, with decreasing prices for renewables, also here electrolysis will be the better alternative on small scale, as well as on large scale. As of today, on small scale, steam methane reforming is not even an option, so electrolysis is absolutely the way to go due to its scalability. The regional waste collection company in Bergen, where we are located, is looking into local production of hydrogen using their waste energy from their combustion facility and using this hydrogen for their waste collection trucks. With Greenstat's aid, this company is now able to realize such a project. On a small island outside of Stavanger in Norway called Utsira, there are plans for an onshore fish farm. Now, if this project is realized, then the energy demand on this island will be greater than the capacity of the grid connected via the mainland. The way they intend to solve this problem is by introducing a windmill to produce a sufficient amount of energy and storing this in via hydrogen as energy storage to secure supply of electricity to this fish farm. And if they decide to go through with this project, Greenstat will, of course, be a part of it. The project closest to realization is the one we're doing for Osland Havbruk. This is an offshore fish farm, which today uses diesel vessels, but they are looking into using hydrogen vessels, and we are doing the study for them. And if that goes through, we will possibly start this project, start building these vessels, maybe early 2019. And another additional advantage of hydrogen being used here is the high demand for oxygen in these fish farms. And as we know, oxygen is a byproduct of the electrolysis. Another project in the making is the hydrogen ferry in Norway, which will serve one of the routes in western Norway. We are cooperating with one of the companies offering to build this ferry, and we would there be the hydrogen producer delivering the hydrogen. This ferry is to be done in 2020-2021. Okay, so hopefully we can be making the first hydrogen ferry happen. Thank you for your attention.
Thank you, Tor, for excellent timing. And you highlighted the application of hydrogen as a storage medium. When renewable energy, of course, the random nature calls for storage, and how hydrogen could be used. The potential of using renewables for producing hydrogen in place of steam reforming was highlighted. So I'm sure there are quite a lot of interested participants here to see the potential of economics of this, and there will be questions, I guess, in the question and answer session. Next, I would like to very kindly invite Mr. An Gravdal. Mr. An Gravdal is the CTO and founder of WinSim AS. I would like to invite you to the podium for your presentation. Thank you.
Dear renewable enthusiasts, I'm very happy to be here today. I'm happy to be part of the Norwegian delegation, being part of this seminar, and being here in Sri Lanka. It's, for me as well, the first time to this wonderful country. I will talk about wind, and it has been a lot of focus on solar today. So maybe this is my lucky day. At least I will not compete for the attention for the audience that is interested in wind. Usually when I present, there are a bunch of presentations on wind, but here I seem to be the only one. The title of my presentation is Wind Variability. How wind varies. We cannot see the wind, but we can feel it. If we go up on the mountain hill, okay, here it's windy. But have you ever been thinking of the fact that if you go up to the ridge, on top of the ridge, okay, it's windy. But actually the wind is accelerated, so it's more wind towards the ground, and it's less wind at higher heights. So this is what we are dealing with. We try to visualize, we try to show you how wind varies. And I will show you what kind of values that will bring, of course, in particular for the wind industry, but also for other industries. First, a few words about the company. I have my background as an engineer. I started as many Norwegian engineers in the oil and gas. But 20 years ago, we got a project establishing a wind atlas for Norway. Norway is quite different from Denmark. The industry started in Denmark, northern part of Germany. It's flat. Whereas in Norway, we have a hilly coastline, and I used the method that I learned in the oil and gas sector. It's a method called CFD, computational fluid dynamics. It's a wonderful method where you can simulate all kind of flow problems. So I used that when I did the Norwegian Wind Atlas. Some years later, we had a software called WinSim, and we have sold it around the world. We have customers in more than 50 countries, and it's a software that helps you design the wind farm in the most profitable way. As I said, it's my first time here in Sri Lanka, but we have had an operation in India for several years, and we have some of the turbine manufacturers and the developers in India as customers. Okay, so let's look at the wind. there is good resources here in Sri Lanka. This is a map we have seen earlier today, a bit different version, but the same content. Good wind conditions around the coast, good wind conditions inland over the mountains. But you need to know something more, because you need to know how wind is at a very local scale. This is a wind farm somewhere in the world, and you can see the turbines. I've colored the swept area of each turbine. The red one is the one that produces very well. The orange, yellow, the white one do not produce as much, and it's due to this fact that the wind energy content is proportional to the wind speed in third cube. So if we are talking about wind variability, and if that's large, the variability within production is even much, much larger. So a turbine can produce a certain amount, but within the same park, another turbine will produce the double. And this you can take advantage of if you can see the wind. Then you will position each turbine at the best location. So this is our technology. We established WindSim 15 years ago, and at that time it was used in the pre-construction phase. And it was used also close up to financing, which means that you have all your measurements and you would like to have an estimate as accurate as possible on the produced production. 15 years later, it looks different. We have a software suite. We do the whole value chain. We do the early screening. We do a wind atlas for a country. And we also go into the operational phase with forecasting and other services. And I will kind of touch upon some of these services that we provide. It's both services, and of course we also sell the software, so you can do your own optimization. So what about optimization? Here we have looked at some wind farms around the world. You find them on Google Earth, actually. You can go down, you can see here is a wind farm. So we have picked some wind farms quite arbitrarily, and we have calculated the produced energy. And then we have used our technology, and we have moved the turbines around. We have moved them to a position which seems a bit more favorable, higher wind speed. Maybe then it's too close to another turbine, and it's affected by the wake of another turbine, so then you have to move that as well. So this is our exercise. And for the 7 wind farms we have looked at, you can see that we have been able to increase the production. This is a thing you do on the computer, but we can increase the production between 3 to 10%, and there is also one outlier here with 30% increase. So that's, of course, the main value by using a tool like WindSim. Then we are also into the operational phase. This is a bit too long to explain, but this is forecasting. So usually when people give you a forecast, it will be the forecast for a wind farm or even for a region. We do a forecast for each turbine in the wind farm. So you can take down the scale from the meteorological models that operates on the whole globe on a 10 or 100 kilometer resolution down to the resolution that we operate, which is a 10-meter resolution. So it's a quite considerable downscaling, as we call it. Then we have another area which is also in the operational phase. This is something we have touched upon in the meetings we had yesterday. And this is a technique called dynamic line rating. So it concerns the high voltage grid. This is a service that we have developed for many years now together with Idaho National Lab with funding from Department of Energy. If you transfer electricity in the grid, there is a limit. If you exceed this limit, the power line will be heated, it will start to sag, and you can create a dangerous situation. So power lines are determined by a static limit of how much electricity you can transfer. But in reality, it will depend on the environment. If there is a sunny, a hot day, of course the line will be hotter as well. If it's a windy day, then the line is cooled, and it's a significant effect. And that's where we can introduce our technology. We can monitor the full line span with our microscale models. We can identify the hotspots, and we can allow you to transfer more. The studies, we have done 4 pilots in the US, and the studies indicate that you can transfer 10 to 40% more electricity if you don't use the static criteria, but use a dynamic criteria. This is for sure something that should be of interest here. We have discussed storage. That's, of course, one solution. But to introduce dynamic line rating will also improve the operation of the grid. Since there has been so much focus on solar, I would also like to say that if you would like to design a solar wind farm, you need to take the solar panels and mount them in racks. So you need some concrete and you need some steel. And how much concrete and steel do you need? Well, it depends on the wind conditions, actually. It's the extreme wind that will determine how much concrete and steel you will need. This is also a service we provide. We can take climate data and we can establish a local extreme wind at exact your solar location. Okay, and then there are other things for offshore, for wakes, it's for advanced measurements of the wind. We kind of interact in these fields as well. I think I will end my presentation here. This is a small fancy animation, but as usually it doesn't work. Here you see the same wind farm as the one you could see at the beginning of my presentation. And as I said, the idea for us is to visualize the flow field. Okay, here it started. So you see it's much more into it than just going up to the mountaintop and feel that, okay, here it's windy. The wind is quite complex, and we have a tool that can show you the full complexity of